Okay, so here we are starting lesson 4. And someone had a question about dereferencing.
Yeah, but you know what, I know it's nothing else that resolved it.
Okay. That's what I should always do when someone asks a question, right? Say, I'll answer that in 5 minutes. And then, okay, so someone's trying to get in. Oh, I'm good. I'm walking. Okay, so before I dive into this new lesson, does anyone have questions? Yes. Namespaces, okay. Okay, so this assignment meeting assignment 2. Okay, so that's a great question, namespaces, and I want to actually talk about that in a little bit of detail before I start talking about the next subject. So let me write that down, and I just want to see if there's other questions about other stuff first. I have a couple of more. So I realized that I guess assignment 2 is due today, right? I have that right. So I realize I'm a little bit behind in terms of, like, I just posted the lesson 3 videos today. Not that you couldn't have made do without them, but because assignment 2 is due today and I haven't done anything, said anything about namespaces yet, I'm going to postpone actually making you do the namespaces thing on assignment 2. And before I even post assignment 3, I'm going to make sure that I put it in there. I have assignment 3 mostly ready to go, but I haven't said in assignment 3 that you're required to use namespaces, so I'm going to add that in there. And so assignment 3 on, you'll be using namespaces. Okay. So basically, the way that namespaces works is that, well, so first of all, the reason we have namespaces is as a way to avoid name conflicts. Okay, so it's like so in case you want to use 2 different classes, somebody written by person A, a class written by person A and a class written by person B, and both classes have the same name, say, for example. Now, that seems a little bit unlikely, but, you know, in really large software projects, you never know, okay? So what are you going to do about that? Well, those people who wrote the classes should have put those classes in namespaces, and so that you can distinguish between the 2 classes that way. So that's the motivation. It actually turns out to be a pretty simple process. All you need to do is, in your header file, you'll just put the whole thing inside I guess I should start out. Hold on. You put the whole thing inside a namespace, and what I'm about to show you is the syntax for that. Okay, but while we're waiting for that to start up, so there's 2 steps, right? The first step is when you're creating the class, you put it in a namespace, which means in your header file, you're going to have to put all of the code in your header file in the namespace, and you're also going to have to put all of the code in your implementation file in the namespace. Okay, that's sort of one side of the process. The other side of the process is then, when you use the class, you're going to want to say using namespace and then whatever you called the namespace at the top of your file. So then you have access to all those things you just defined in that namespace. So that's the first level explanation, right? That's the basic rule. So the other complicating thing that came up in the question a minute ago is oops, that's not what I meant. What am I doing wrong?
Yeah, give it a name.
Okay, so at the top of here's the syntax for creating a namespace. Okay, just at the top of my file, I'm going to say using namespace std. Sorry, that's totally wrong. Totally spaced out for a second there. Okay, I'm back. Namespace. I could say something like Dave's feet inches, open curly brace. Okay, and then everything inside here is just the stuff that was already in my, let's say this is the header file. It would be the, class, feet, inches, and then dot, dot, dot. There's the end of the class, semicolon. And then there's the end of the namespace. Okay? So in other words, pretty much all of the code in there is going to be defined to be inside this namespace. And all that means then, is that in some other file that's using this class, you can't actually use the word feet inches unless you somehow indicate that you are using the Dave's feet inches namespace. Okay? So in really simple terms, what that means is when I go to my client program, so let's go down here and pretend this is a separate file, my client file. I'm going to say at the top, using namespace Dave's feet inches. Okay, and so that means now any place in that file I can use the word feet inches, for example, because I have indicated that I'm using that namespace. Any questions so far?
Call it directly to its full.
Yes. Yeah. So there's other ways to do this, and then sometimes you're going to have to because of the complication about putting this statement in header files. But before I get there, I want to see if it makes sense so far. Okay, so this is kind of like the first level explanation, the basic rule, how you can get this to work, and then there's a couple complications that I still want to talk about. Go ahead.
Naming conventions for namespaces?
Okay, that's a good question. Naming conventions for namespaces. For now, I'm gonna say we're gonna be a little bit informal about it. Okay, so for now, you can just put your name and the name of your class like I just did up here. I'm trying to remember. Sometimes what people do is they put like if they have let me think about this. Yeah, I'm getting my languages mixed up. So let me get back to you on if there's really some serious conventions about this that you need to know about. For our purposes for right now, just put like maybe your name and an underscore and the name of the class or something like that. Okay? Or if you don't want to do that, you can make something up and I won't care at this point. Okay? Okay, so as with any namespace, there's different ways that you can indicate that you're going to use it. It may be the case that this is the only way you've ever done it. That's possible. Just say using namespace std at the top of your file, and that's it, all taken care of. Okay. The problem is that, like it says in the textbook, you should not ever say using namespace whatever at the top of a header file. Why do you suppose that would be?
Because every time you use that class, it's going to bring that namespace into the program.
Right, so every time a client program then includes that header file, the client program is unwittingly also now using that namespace. And the client program may not want to be using that namespace. Okay? So in a header file, instead of doing it like this, instead of saying using namespace std at the top, okay, don't want to do that, right? So what you do is just every time you have a need to use the std namespace, for example, inside here, maybe you have iStream, right? You would say, instead of just saying iStream, you would say std : iStream. Operator, let's see, input, so that would be the extraction operator. And then inside here again, right? std iStream & in const Okay, so that's an alternate syntax for using the standard namespace that you would want to use in a header file instead of just putting the using at the top. Any questions about that? Yeah. Yeah, you can still include iostream at the top. That doesn't hurt anything. So yeah, I guess I should clarify that in my little example here. Okay, and then now just for the sake of completion, so for the sake of covering everything, so you know it, there's a third way to specify this that's kind of in between these two, right? So the first one is very broad. It's like, okay, from now on, anytime you see an identifier in this file, you can use it if it's in the standard namespace. That's the big one at the top, right? This one I've shown you here is very, very specific. It's just saying for this particular identifier right here, it's use the one from the standard namespace. Okay? So there's one that's kind of in between that. I could say using std : iStream. Got that right? And so what that means is that from now on, I can just use iStream by itself, and the compiler will know that I mean the iStream from the standard template library. Okay? I'm not expecting you to use that one, probably. Any questions about namespaces? I'm afraid it may feel a little mysterious at this point, but I think once you sit down and try it out, it's not going to be that big a deal. And my suggestion would actually be on assignment 2, because assignment 3 is going to be pretty complicated with like 5 classes, I think. So you may not want to hit namespaces for the first time on assignment 3. So you might want to just try on assignment 2, once you've got everything perfect, everything working, try putting this namespace stuff in there to see if you can get it to work. And if you do, then you'll be like, okay, now I know how to do it. Okay? That's my suggestion. Any questions about namespaces? Yes?
If you were to do it like that, would you have to do it for all the different?
Yeah, right. So basically, if I do it this way, what I do is I just have to make sure that any word that I use in this file that's from the standard namespace, I take care of it right here. So C out, C in, whatever. Okay? All right. Let's move on and talk about lesson 4, the next lesson. Lesson 4 is going to be about links, data structures, but I guess I could be more specific and say it's going to be about linked lists. Oops, that's not what I wanted to do. X. I wanted paint. What would life be like without paint? Okay. At this point, I'm not caring too much about the code over here, but I've got it set up so that later on, if I do care about it, I can use it. So a linked list, I think I've sort of talked about this in very vague terms before. Actually, let me back up a little bit. First, I want to talk a little bit about how the class is going and with the textbook and the lessons and some things like that, okay? Things are going to shift a little bit now. Okay, first 3, what I call lessons, which correspond to the first 4 chapters in the text, right? Basically, they were sort of lesson-centered, and the textbook was sort of backup material, right? Does that make sense? So, but you could probably get by just reading the lessons and listening to the lectures, and if you didn't read the text, you could probably survive and pass, right? We're kind of shifting gears in this lesson, which corresponds to chapter 5 in the text. And I'm going to be following the text more closely. Okay, so when I think about, okay, what do these guys need to know by the end of this lesson, what I'm doing is I'm going and I'm looking through chapter 5 of the text, okay? So you can depend a little bit better on the text probably on this one. And I'm not going to be providing written lesson on this one. Okay? So it's a little bit of a shift. The assignment may even be from the textbook. I haven't figured out what assignment 4 is going to be, but it might just be a programming problem from the textbook. Okay? Having said that, I have to say something about the textbook in chapter 5. And that is that, so when I was deciding what textbook to choose for this class, I really liked the textbook that I chose a lot for many, many reasons. But there's one thing that I really don't like about it, and that is that something that the author, is it author or authors? Author, I think, is just Maine. Is it Maine or is it Maine Savage? Maine Savage, okay. One thing that the authors choose to do in chapter 5, and I'm not sure if this will make sense or not, but I'll just throw it out there anyway. It'll make sense later. They choose to create a node class for one, so each thing in a linked list is called a node. They choose to create a node class and create sort of a toolbox of functions for that node class. And then, so they kind of build this layer, and then all of the code that they do for the rest of the book, pretty much, is built on top of that layer that they created. And I don't think that's the right way to do it. So we're not going to do that. We're going to do more on the side of pretty much just creating the code from scratch each time. A couple reasons for that. Well, I guess the main reason for that is that doing it the way he does it really introduces a lot of complexities into what he's doing. And so there's a few things in chapter 5 and later on that he'll talk about these things that seem really complicated and it's really hard to understand. And it turns out that the only reason that he even has to deal with them is because he's created this linked list toolkit, he calls it. So that's one reason. And the other reason is that I like the idea of, the part of the reason you're here is to learn how to write this code. So I prefer to have you just write it from scratch when you're doing your assignments. Okay? So that's going to be a little bit confusing, I know. And I almost chose not to use this textbook just for that one reason, but I really like it in most other ways. So as you're reading chapter 5, you're going to be reading about this linked list toolkit, and you're going to have to read about all of these functions that he's writing to be part of the linked list toolkit. And it's important to read about those functions because the code in those functions is important and the algorithms is important. But you just have to keep in mind that we're going to do things a little differently. In our case, it's not actually going to be a function in a toolkit. It's just going to be a function that we rewrite every time we do another implementation. Okay? So just give it a try and let me know if you have questions about how that works when you get to chapter 5. Any questions about that? Okay. Here we go. So let me draw a picture of a linked list. Let's see, first of all, this is going to be a pointer. This is going to be a node. And I can draw these so they're sort of in order, but maybe just to illustrate the fact that these are just sort of picked out of random places in memory. I'll just kind of draw them randomly around the board. Okay, so here's a bunch of things that we're calling nodes. Okay, so let's say this is we're trying to represent a list of integers. Okay, have we done anything like that yet in here? I'm trying to remember. What have we had? We had a dynamic array, but we used it to store characters. So I guess we haven't really done it. So we could use an array to store a list of integers, right? You probably saw that in your introductory programming class, hopefully. Using an array to store a list of integers. So what we're going to do right now is the exact same abstract concept, right? List of integers, but we're going to use a completely different data structure, a completely different type to actually store the list of integers. Okay, so let me draw a picture. The way this is going to work is, here's my list variable, and list is going to be of type pointer to node, and each node is going to have an integer and then a pointer to the next node. So each node has two parts. So there's a pointer to the first node. Okay, and then the top, we'll say that the top part of each node is the data. Okay, so in our case it's going to be an integer, but it could be a feed instance object, it could be a fraction, it could be a string, a MyString, okay, it could be anything there, but we're going to make it an integer. The bottom half is a pointer to the next node. So just to be kind of, random here, I'm going to say that points to this one. Okay, and then this one's going to point over to this one. And then this one is going to, I wonder, oh well, let me, this one is going to point to that one. Okay, and then where's this one going to point? Right, that one's going to be null. Okay, we haven't talked about null in a while, but when I first introduced pointers, I think probably the first day, I said there's a way to indicate in C++ that a pointer doesn't point to anything, and that's with the null. It's not actually a reserved word, but the null constant. So the way we indicate that in a picture usually is we just draw a diagonal through it like that, and that's our way of saying that that points to null. The value of that is null. Okay? There's a picture of our linked list. I could put some identifiers in here. So this is going to be whatever we call our list. So I could call it list. And then each of these is a struct or a class, one or the other, okay, depending on the implementation. But in either case, it's going to have data members, right? So each of these is going to have a, I guess we could call it a data member and a next data member. Okay? Now you're going to see this called differently. In the text, I think he always calls this one link. So it would be, instead of saying list arrow next, like I'm used to doing, in the text he says list arrow next. In the text he says list arrow link. Okay? Just two different conventions. I grew up using next, so I'm gonna keep using next. Okay, and then of course each of these would have the same thing, right? So this one here would also have data next data next data next. Okay. Any questions about that picture? Oh, I guess I should put some data in here, right? Okay, so this is how we would store the list with 4, 17, 13, 91. Okay? Well, this, okay, that's a good question. This data member right here, this is a node. This data member of the node is named next, right? But what this is a picture of is that the value of that data member named next is null. Okay, so the fact that it's called next doesn't change. It's always going to be named next. Null is just what's being stored in that place called next. Okay, so you ready to talk about how this looks in code? Let me just say one more thing. I just want to emphasize sort of, this is kind of a foundational concept that you all really need to be clear on, and that is sort of the difference between when we're talking about sort of the abstract concept of list and the implementation of a list, right? So I'm talking about the abstract concept of a list of integers. That's what I'm talking about here, a list of integers. I can implement that in many different ways, one of which is pictured right here, or I could just implement it as an array of integers, right? That would work too. The whole point behind classes is that I can write a class called, for example, int list type, and someone could use that class to keep track of a list of integers, and they will have no idea, perhaps, whether I implemented it as an array or as a linked list. And as a matter of fact, I could take my class back change the implementation from an array to a linked list and give it back to them, then it wouldn't matter, right? Everything would still work. Does that kind of make sense? So we've got, what we're talking about here is, okay, we already know one way to implement the abstract concept of list of integer. Now we're going to talk about another way to implement that. Okay? So that's where we get the big fancy word. Have you heard the phrase abstract data type? That should be like that's probably like the central word in this class, abstract data type. I remember when I was TAing this class, I don't want to tell you what exactly, a long time ago. And the instructor was always saying, the main theme of this class is that data abstraction is good. What does that mean? Data abstraction is good. Okay. That means that I want to write code so that somebody can use my code to store a list of integers with all of the details about that abstracted out, right? All the details about that are taken out, and the user of that class doesn't have to know anything about them. Okay? So that's data abstraction. Okay. Sorry, that was a long time for me to talk without drawing anything or typing anything. I'm feeling uncomfortable. Yeah.
Would it be appropriate to ask now, like, use cases for linked list versus array, or is that?
Oh, okay. Good. No, I think that's a good question, except that means I have to talk even longer without typing anything, but I'll give it my best shot. So the question was, when would you want to use a linked list to represent your list of integers, and when would you want to use an array? Was that your question? Yeah. So you might need to know a little bit more about linked lists before I can answer that, I suppose, now that I think about it. But that's an excellent question, right? That's one of the key questions in the textbook that he's asking a lot. And one of the, if you look at the objective, if you go to the, Santa Rosa Junior College website and look at the course objectives, one of them is going to say selecting appropriate data types or appropriate implementations for abstract data types or something like that, right? So you have to weigh the advantages and disadvantages and figure out which one's best. That's one of the things we're supposed to do in this class. So make sure you do ask that question. Let's talk about linked lists a little bit more first. Okay. Let's see some code. And I actually think that the best way to do this is to show you the client program first, right? Because that's what we're trying to do. What we're trying to do here is, okay, the client programmer needs to be able to do this certain thing, needs to be able to store a list of integers and do some stuff with it. What is that going to look like exactly? We need to know that before we start writing it. Okay, so let me just type some stuff here. So I would like to be able to int list type list. I'd like to be able to declare something that to be of type int list type, or list of int. Does that make sense? Okay. And then I'm going to put a couple other declarations up here because I happen to know that I'm going to want them eventually. So enter a number to insert. So just to get rid of some squigglies, I'm going to put this at the top. And I'm going to say while num is greater than or equal to 0, list.insert none. Okay, now I could stop there. That gives me a couple of things to do to write my class, right? It means I'm going to have to write a constructor, and it means I'm going to have to write a member function named insert so that I can insert things into the list. Okay? The thing I don't like about this is that I'm going to run this, I'm going to have absolutely no idea whether anything actually happened or not, right? So I'm going to add one more thing here. I'm going to say list.print. Okay? I'm going to stop there and we're going to take a break. And I'm going to start up again at 9:30. And so I'll see you in 10 minutes. Make sure you get some fresh air or take a walk or whatever you need to do. Okay, so one thing I wanted to say, just to kind of relate this back to the textbook, and what we're going to be talking about for the rest of the semester, really, is that this thing we're talking about here, this int list type, is called a collection, right? So one of the chapters in the text, is there a chapter? Yeah, one of the chapters, chapter 3 in the text is called container classes, right? So that's what this is about. A container class is something that contains other types. In this case, it's a class that contains ints. And a list is just one type of container, right? There's different kinds of containers. In the textbook, one of his containers that they talk about over and over again is the bag container, right? And actually, he calls it a bag, but in the C++ standard template library, it actually does have another name, like a real name that's more formal, and that is set. Actually, I think it's a multi-set. In this bag, you can have more than one of the same thing, right? So the name for that container in the C++ standard template library is multi-set. And there's also in the C++ standard template library, there's a container called a set. The difference between a set and a multi-set is that in a set, you can't have repeated of the same item. You can't have the same item in there twice, right? So if you've taken math at all, you'll recognize that that's what a set is, right? You can't have more than one of the same thing in a set. Anyway, so we're going to be doing a lot of, for the next few weeks, is talking about different kinds of containers that you can have and what the best way to implement them is. All right, so here's our client code. What we need to do now is we need to write our class declaration, and then we need to write a constructor, an insert function, and a print function, right? Let me just say that most of the containers that we're going to deal with in the end, formally, aren't going to have print functions. What they're going to have is they're going to have some way that allows you, the client programmer, to iterate through the items in the container. And so then the client programmer can print them by iterating through the container. But we're not quite there yet, so just in order to be able to see that what we're doing is actually having some effect, or is correct, I'm going to provide a print function. Okay, so class int list type. I like to indent that. Okay, so our member functions are constructor, and at this point we just have a default constructor, right? An insert function, so void and a print function. And our private data member is going to be simply a pointer to what? Sorry? A pointer to the first node, okay. So, but when we declare a pointer, we have to declare it to be a pointer to some type, right? We can't just say, oh, this is a pointer, and I'll tell you later what it's going to point at. Okay? You might, right, so intuitively the first thing you might think of is, well, I want a pointer to an int, right? But are these pointers pointing at ints? No, they're pointing at nodes, right? So we're going to have to first figure out how we're going to define a type called node. So this is where there's a lot of different ways to do this. In the old days, before object-oriented programming, we would just create a struct, which is if you're not sure what a struct is, just think of it as the same thing as a class, except the data members aren't private, so anybody can just go grab them. And then classes came along, and so another option became declare someplace else, declare a class named node. So don't write this down, but that would look like class node, and then private, and then I would have int data, and then a node star next, like that, right? Okay, oops, yeah. Okay, so that would be a node class. No member functions at this point, right? Just data. This is actually what he does in the text. The thing that makes this complicated is that now in my int list type class, every time I want to get the data member or the next data member, I have to go through like an accessor function or a mutator function to either change it or get them. Does that make sense? So I cannot, in my insert function, in my int list type class, I can't access this data member directly. I have to have my node class provide like a get data and a set data and a get next and a set next. Does that make sense? Okay, so that's what he does in the text. And so all through all of his code and all of these functions, instead of just saying .next or .data, it's going to say I don't remember what he calls it exactly, but it might be called get data with open close parens and set data with open close parens. And I find the syntax to get quickly sort of confusing and convoluted. So that's one of the reasons that I'm not doing it that way. And I don't really see that there's a point in it because, well, let me just stop talking about it because I'm going off. Here's how I'm going to suggest we do it. I'm going to say in the private area of my int list type class, I'm going to say struct node and do it here. Okay, so now it's private in the sense that only member functions of the int list type class can get to them, right? It's not a completely separate object from the int list type class, but it's still private from anybody who's using the int list type class. Does that make sense? Yeah.
So why are you building the struct node instead? I mean, why not do list type connect?
Because, okay, I see what you're saying. So why? Is this thing right here an int list type? So let me see if I can repeat the question. Why don't I just make? Let me finish this up, and then I'll. The question may be easier to answer. Okay, so before I answer that, let me just make sure everyone's with me on this. So what I have now is, oh, I still need a data, right? Oh no, okay, data. So what I have is I've got a list, an int list type class, and it just has a single data member, which is a pointer to a node. Okay?
I get it.
Okay. And then, I guess the other thing I wanted to point out here that's sort of interesting, I mean, I could probably just put this code up here and you wouldn't even realize this was happening, but notice that I'm actually referring to my node struct even before I have finished defining it, right? So that's a little bit tricky, and C++ actually, in its syntax, has to make a special exception to make it so that I can do this. Otherwise, I wouldn't be able to create nodes I wouldn't be able to create objects that have pointers to other objects of the same type. Okay. So it would be. The question was, why don't I just make list be a pointer to an int list type object? Or yeah. And the answer is that it actually can be done that way. Although I have to admit that it's harder for me to envision it that way. I've seen it done that way, but I think this makes a lot more sense, right? Int list type is not a node. It's a list. And it's implemented with a pointer to a node. So that's what we're doing. Okay. Everyone okay with that? Yeah.
Is giving the struct method going to change how we refer to nodes in the implementation?
Actually, as it turns out, it's not going. Well, you mean rather than the class? You mean because I'm using struct instead of class?
Yeah.
Yeah. So the question is the fact that I'm using struct instead of class going to change how we refer to the data and the next? And the answer is yes. I'm going to be referring to the data and the next just directly by using their names now. Whereas before, if I had defined it as a class, I'd be having to say get data, get next, set next. Function calls, act to accessor and mutator functions. Okay? Good question. Yeah?
If list type has only one data member?
Correct.
So node is not a data member of it.
Correct. Node is not a data member. It is a type that is being defined inside the int list type. Okay? And you can declare types inside a class. That's not uncommon. In fact, we'll see more of that. Okay? Any other questions? Okay. So shall we try writing a couple of these member functions? Let's start with the constructor. So int list type int list type. What do you suppose we're going to do in our constructor? We want to create a list with no items in it. What's that going to look like in this picture? A list that points to null. So let me draw you a picture of an empty list, okay? Okay, that's a picture of an empty list. So how do I say that here? How do I turn that picture into code? List gets null. Okay. Any questions about the constructor? Yes.
Would you ever want to create an empty node? Does that make sense? So initialize a new node and set that next pointer node?
Would you ever want to do that and have it just be kind of sitting there, not really representing anything? Is that what you mean? And then when you had one item in the list, what would that look like? Wait, so let me repeat the question. The question was, would you ever want to just have the default constructor create a list with one node in it that had garbage as the data? So, and I'm going to answer that, but first I want to ask, okay, if you did that, what would a list with one item look like? The same, except that the garbage would mean something. However, and we're actually going to talk about this, it turns out that you can just turn your brain off for a second here if you don't want a sneak preview, but after we finish this first implementation, I'm going to do it over again with a implementation where we actually have a dummy node at the front of the list. And it just sort of turns out that having a dummy node, and like you described, at the beginning of the list makes some of our code a little simpler. So in that case, a list with one item in it would have a node with junk in it pointing at one real node. So there's always this dummy node at the head of the list. So we'll talk about that later. All right, turn your brain back on now if you had turned it off. Any other questions about our constructor? Okay. It turns out that print is actually a lot easier than insert. So even though it kind of seems backwards, I'm going to do print first. Okay? So let's pretend we've, just for the sake of helping us write this print function, let's pretend that we've got this list here with 4 items in it and we want to print it. Okay? So that would be void int list type : print. What do you suppose we're going to do? Go ahead.
You're going to do a while loop
Okay.
while the pointer isn't starting at null.
The pointer isn't equal to null. Okay.
Are you doing that to print out the int?
Okay, so how would I say that? See how what? So I can't just say data because I have to know what object it is. So I can't just say data because the calling object is an int list type object, and int list type doesn't have a data member. So what I want to say here is basically what you're doing here is you're kind of saying, okay, let's have a pointer that's going to point down to each node in the list sequentially. That makes sense? So I might call that cur pointer. Okay. And so then I'm going to say while cur pointer is not equal to null, what do I want to see out? Say it again? Well, no, that's the right idea, but node isn't a variable, it's a type. Right? So the thing in front of the dot should be an object.
What
do you think? So now list is going to be the list data member of the calling object, right? And so if I go through the list and I keep printing list arrow data, that's always going to be 4. Right? Because list points to the first item in the list. And we haven't done it unless we're going to do something in here to actually change what list is pointing at, which I don't think we want to do. Whoops, did I do that wrong? Okay, so it's not going to be list here. What's it going to be? Cur pointer, right? That's cur pointer, I said, is the pointer that's going to point to each node in the list sequentially. Is there a better, what am I trying to, not sequentially, there's a better word for that. In order, whatever. Okay, you know what I mean. So cur pointer. Okay, what else do we need to put in here? Okay, so we have to say cur pointer gets, make cur pointer point to the next node, right? How are we going to say make cur pointer point to the next node? Let me draw a picture of that so we make sure we get it right. And also just because I like drawing pictures. So here's our, what happened? Here's our pointer that we're calling cur pointer. Okay, and let's say that it was pointing at the 4. And we want to change this arrow so that it's pointing down here to 17, right? So how are we going to do that? Cur pointer gets next. What do you think about that? Okay, so right now if I say next, again, if I say next by itself, that means the next data member of the calling object, which is something of type int list type, which doesn't have a data member named next, right? I'm actually kind of surprised that it's not giving me a syntax error. But anyway, so really what I want here is to say cur pointer gets something arrow next. So node isn't, I can't use node here because node is the type, right? That would be like using int or something in the place of an int variable. What I need here is not the word node, but I need some variable of type node here. And the variable of type node that I need here is cur pointer. Okay, so take a close look at that because you're going to see that hundreds of times in the next month. Cur pointer gets cur pointer arrow next. Okay, so that means here's cur pointer, right? When I say cur pointer gets, that means make cur pointer point to, right? Make cur pointer point to cur pointer arrow next. Well, actually, I guess I need to say that slightly differently, right? Make cur pointer point to the same thing that cur pointer arrow next is pointing at. Okay. So let me just draw that, and then I want to go over that a little bit more and ask you questions. But let me draw that first. Okay. So after I execute this statement, which says make cur pointer point to the same thing that cur pointer arrow next is pointing at. I'm going to have this. Question?
It's just really simple. I missed the part where we divide cur pointer as a pointer type node.
Okay, good question. We haven't even declared cur pointer at all yet, right? At this point, cur pointer is an undeclared variable, which is probably why it's just giving me a syntax error this first time, and then it's just not even trying after that, right? So let's digress for a second and let's back up and let's declare cur pointer. How am I going to declare cur pointer? Sure. Is that right? So hold on for a second, okay? I can see that this is confusing to keep it straight between what's an int list type and what's a node, right? We have two different types going back and forth here now. We've got a type called int list type, and we've got a type called node. So do we want cur pointer to be a pointer to a list of integers, or do we want cur pointer to be a pointer to a node? We want cur pointer to be a pointer to a node. And we say that by, how do I type that? Node star cur pointer. Okay. Is that everything we need to do to get things set up correctly? Go ahead.
You could assign cur pointer equal to list.
Cur pointer gets list. That make sense? That's what I drew when I first drew the picture up here. That's what I had set up, right? Cur pointer was pointing at the same thing that list was pointing at. Okay, so that's correct. Let me talk a little bit about. I'm going back to my first lecture on pointers here for a second, but just to make sure everyone's clear on how pointer assignment works. Okay, when I assign one pointer to another one, at the most abstract level, which is the level that we usually think at, all that means is make one pointer point to the same thing the other one's pointing at. That's what a pointer assignment does. Okay? If you want to look at the concrete level, that means when I had my assignment statement that said cur pointer gets cur pointer arrow next, this right here was cur pointer arrow next, right? So if I take the contents of that variable and put those contents here into cur pointer, that's what an assignment operator does, right? What I'm basically doing is taking this memory address that's stored here and putting it into this variable here, which is the same thing as saying make it point to whatever cur pointer arrow next is pointing at. All right, so if that made no sense, you might want to go back and take a look at lesson 2 in the section called pointer assignment, or you can just keep it at the abstract level, right? Which is when I say one pointer gets another one, that just means make that one on the left point to whatever the one on the right is pointing at. That's the conceptual way of looking at it. Okay? Anybody want to ask a question about that?
You have nodes and then the attributes, and sometimes you have the nodes but the attributes are I understand that this can be
sometimes I have node. What do we see? Oh, so every time I see a star with node, I think it's star. Node star something, right?
Yeah, but sometimes it's under star. You say node and then you just say star.
Oh, I see what you're saying. So sometimes I do it like that.
Yeah, what's the difference between the
There's no difference. Same thing. Yeah. I actually think that I recommended in my lecture on pointers that you put it over here next to the variable, because that was a way of making sure that it wasn't ambiguous if you had more than one on the same line. But But now that I'm like just typing away and not really thinking about it, my habit is to put it on the type. So I don't know. We'll see how it goes. You can do whatever you want on it. Okay. Okay, I think that's actually it for our print function. So take a look at that and see if that makes sense. See if you want me to, I don't know, start from scratch and go through it again. So I think I'm going to do that, even if most of you think it makes sense pretty much. So let me just go through this from scratch and make sure we're all on the same page. So I'm going to start from just my list like this. Okay, so this is what I have when this function starts. And now remember, list is a data member of an object. Okay, but that object only has one data member. So the first thing it says is declare a pointer to a node and name it curPointer. So I'm going to create a pointer to a node called curPointer. Okay, and if I just said that without the initialization, it would be junk in there, right? It would be an uninitialized pointer. But I'm assigning it so to point. I wonder if I'm like really loud over there too. Should I talk quieter? That is pretty loud. My initialization says make that pointer point to the same thing that list is pointing at. Okay? So that's after this first statement right here. Okay? Now the next thing says, while curPointer is not equal to null, is curPointer null? No. So I'm going to print out curPointer arrow data, so the 4 comes out. And then I'm going to say curPointer gets curPointer arrow next. That means make curPointer point to the same thing that curPointer arrow next is pointing at. Right? curPointer arrow next is pointing at this. So that says make it point down there. Okay? So now I'm at the bottom of my while loop, so I go back up to the condition. Is the condition true or false? The condition's true because curPointer is not equal to null, right? So see out curPointer arrow data. So I see out the 17. And curPointer gets curPointer arrow next. So curPointer arrow next is this thing here, right? So that means make curPointer point to the same thing that curPointer arrow next is pointing to, means that, right? Okay, so going a little faster now. curPointer is still not equal to null, so now I'm going to print curPointer arrow data, which is 13. curPointer gets curPointer arrow next. So now curPointer is going to point here. Then I go back up to the condition. curPointer is still not null, so I print out the 91. And then I say curPointer gets curPointer arrow next. What does curPointer arrow next equal at this point? Null. So this is saying curPointer gets null. So now I've got this. And now when I go back up to the while loop condition, curPointer not equal to null is false, and I'm done. Okay, so I printed out 4, 17, 13, 91. Any questions about that? I should have done that with a shorter list so it didn't take so long. Okay, I think we're done with print. That looks good to me. The one thing I would throw out is that I'm going to just tell you now, sort of as a sneak preview, whenever you write a function involving linked lists, you're always going to want to stop and think and make sure that you've handled all the possible special cases, the boundary cases. So make sure you've thought about, is this going to work when list is null? Is this going to work when there's only one item in the list? And then these next two aren't going to apply to print, but they're going to apply to insert, okay? So when I'm inserting an item, does this work if I'm inserting the item at the beginning of the list? So that's the third special case. So for insert, or if I'm deleting something or whatever, just make sure it works if it's happening at the beginning of the list. And then the fourth special case I would say to always look at is make sure this works if it's happening, if it's something that's happening at the end of the list. Okay. So make sure it works if the list is null. Make sure it works if there's one item in the list. Make sure it works if something's happening at the front of the list. Make sure it works if something's happening at the end of the list. Okay? So the general case is it's a list with more than one item in it, and it's happening somewhere in the middle of the list. Right? That's the case we usually start with and think about it that way. I mean, not necessarily start with, but that's the general case if we're not thinking about the boundary cases. Okay, those four things. That's the source of a lot of trouble, a lot of bugs, a lot of crashing programs when you don't handle one of those four cases in your function that is dealing with a linked list. Okay? So, as I was writing this, I was thinking, okay, really only the first two special cases apply. Does this work when the list is null? Yeah, because cur pointer not equal to null is going to be false the first time. And does it work if there's one item in the list? Yes, it does. Okay? All right, so insert. And we're inserting that thing that's in the parentheses there. Anybody want to take a shot at how to start this, or just make any kind of an observation about what's going to go on here? Go ahead.
You're going to have to allocate some memory.
Okay, so we are going to have to create a new node. So this function is inserting a node into the list. That's going to involve creating a new node, and that's not a bad place to start. We might as well start there. Node star temp. Okay, so I'm creating a new node. Now remember, the nodes are all actually on the heap. I have thought about that several times as we've been talking, and I keep forgetting to actually say it. Right? All of these nodes are actually on the heap. They're all dynamic memory. Okay? So in order to get a new node, I have to declare a pointer to a node, and then use the new operator. Node star temp gets new what? What do I want? A new what? A new node, right? So allocate a node and make temp be a pointer to that node that you just allocated. Okay. Then I need to put the data in, right? So how do I do that? So I know that I want to put the data into this new node I just created, right? And the new node, how am I going to get to the new node? It's got to have temp, right? Got to start with temp. Temp arrow. So remember, temp arrow means temp is a pointer, dereference the pointer. So now I'm talking about the actual node itself, and select which part? The data part. It's none. Okay, so remember, if that arrow notation is still a little mysterious to you, the deal with that arrow notation is that within 2 weeks you're going to have seen it so many times it's going to be like second nature to you, okay? But if you're still kind of wrestling with it, this is what it means, right? Star temp dot data. Right? Temp is a pointer to a node. Dereference that, so you're actually talking about the node itself, and then say dot data. Was there a question? Yeah. On the what?
On the reading?
On the reading? Only when you print?
That's what I thought it was.
I'm not sure why. I'm not sure where that would come from. It's not true. Okay. Yeah, you're going to see that arrow a lot. Okay, so we've done the first step, which is we have created a new node. What do you want to do next? Oh. Where do we want to insert this thing? Well, it doesn't really matter, right? I'm not keeping an ordered list. I'm just inserting it. Doesn't matter where, right? So where would be the easiest place to insert it? At the beginning, actually, be easier, right? In order to insert it at the end of the list, you'd have to have like a while loop and move the pointer all the way down to the end before you could insert it. But inserting it at the beginning is actually going to be pretty easy. So I'm sure if I sat down I could figure out better ways to do this. But until then, we're stuck. Okay, so I've created, let me draw a picture of what we've done so far, okay? I've created something called temp. Temp is a pointer to a node. Okay. I suppose it might have been a good idea to call this temp pointer. I should have done that, but I'm not going to change it at this point. And I also created a node. Oops, that's not what I meant. And I set the data part of this node equal to whatever num was. So let's call it, 47, whatever num was. And I made temp point to that new node. Okay, so that's what I've done so far. Now what I want to do is I want to insert this node at the front of the list. Just looking at, forget about C++ for a second, just tell me in the picture what I need to do. List needs to point to this new node. Okay, so let's talk about the order next. But So two things need to happen. I need to make this arrow here, I need to make list point at the new node, and I need to make temp arrow next point at list, right? And the order is important, right? Because if I make list point here first, then all of this is gone. Okay, so I'm going to say temp arrow next gets list, right? So make temp arrow next point to the same thing list is pointing at. And then I want to change what list is pointing at, right? Make list point to the same thing that temp is pointing at. Okay, so that means oops, sorry, yeah, that's right. Okay. Make list point at the same thing that temp is pointing at. Does that look good? Have we successfully inserted that new node with the 47 in it into our list? Yeah, I think so. Okay. So we're not quite done with this. This actually is correct so far. What do we have left to work on this function though, still? Go ahead. Delete temp. Let's hold on to that thought, okay? What I was looking for is, what we've done so far is we have written this so that it works in the general case, right? So we want to check those boundary cases I talked about. Is this going to work when list is null? So temp arrow next gets list, so temp arrow next gets null. List gets temp. I think that's right. So maybe we are done, actually. I'll leave that as an exercise, and we'll talk about it next time. Do we need to delete temp? Let's see. I'm creating temp. Temp is pointing to a new node. Yeah, that's kind of a tricky one, huh? I'll leave that as an exercise too, and we'll talk about that next time. All right. See you guys next time.